Today, or well, right now, we are going to be doing recursion. I'm going to try to do tail recursion as well as backtracking. If I have enough time, I don't want the video to be too long, but I'll try to cover most of it. So we'll head right into recursion. What is recursion? Recursion is a normal for loop that goes backwards. Now you can have it go forward, but in most cases, it would be easier to go backwards. So why or how does it work? First, there's a couple things you want to know in a recursion or a recursive case. You have something called a base case. What is this base case? Or what does it mean? Base case is basically what you're trying to go to. Okay? So if I want to get the sum of this array as a recursion, or as let's say as a for loop, what you'll say is I, or well, let's do I. So you'll do I plus I at the first indice. Remember, for loop will start at 0 to the array length, and you'll keep adding on to it. So you'll do I plus whatever the number here, plus whatever the number here, and then you'll add on to it until you reach the end, and then you will add them all up and return. Okay? Now, in a recursive case, your base case is when you're at the end of the array, and you start at the end of, so your base case is at the beginning of the array, and you start at the end of the array, which is, in this case, would be 4, indice 4. Not the number 4, the index 4. So what do you do here? First, you go at the index 4. You're like, okay, so this is 4, get the 4, plus the one behind it. So I'm going to call the function again, and I'm going to pass it the indice 3. And this function should return me whatever is here. Okay? So you see here, this function, I'm going to pass it the indice 4. 4 plus whatever is at the index 3, plus whatever is at the index 2, plus whatever at the index 1, plus whatever is at the index 0. Now, whenever I do 4 plus, I'm going to call the function at whatever the index 3. And 3 won't return because 3 will also call the function again and be like, what's at the index 2? So on until it gets to 0. And the reason 0 is the base case is because once you get to 0, 0 is not going to call the function anymore. It's going to be like, oh, that's it. I'm at that. So it's going to return me 7. This 7 actually gets returned to the 1 because the 1 is called the function. The 1 will do 7 plus 1 will be 8. And then that will be returned to the 2. The 2 will be 8 plus 2, which is 10. So 10 will be here. And then 10 plus 3 is 13. And well, it's going to be the numbers, not the indices. But this will be 13. And so on. And it will add up. And then this initial call will return you the total. That's why if you don't have the base case, your recursion function will keep going backwards. And then you'll probably get like an out of bound error in this case. But sometimes you don't get an error, you get an infinite recursion, which is messy, and it will burn your server. So do be careful with it. And so that is how you implement a recursive. All you need is a base case, which is usually the way you think about recursion. Whenever someone tells you recursion, you read the problem, and then you'd be like, okay, where do I start? Where do I end? Do I start at 0? Well, let's say index is 0. Sure. Or if they tell you, give you numbers. Let's say they tell you add numbers so the sum is 10. So usually in a for loop, you will keep adding numbers until they add up to 10 and return those. But remember, we said we go in reverse in recursion. So we will minus from 10. Like, okay, so the target is 10. We're going to do target minus 3, target minus this, target minus that, and then go backwards like this. And so our end case is when the target is 0. That's going to be our base case. So usually you'll have where you start, where you end. If you want, think about it like a for loop. Where do I start? Where do I end? And then, if you want a recursive, do it in a recursive way, flip that. Make whatever you chose at your first to be the end, and then whatever is at the end will become your first. And if like that's your first, then that would be your base case. And so now we're going to try to implement it using some coding back problems, because you will bring some questions from here for sure. So do practice your coding back. Okay, so how do we do a factorial, or what is a factorial? A factorial is very simple. It is, so if I tell you 5 factorial, then the answer would be 5 times 4 times 3 times 2 times 1. And then once you get to 1, you're like, that's it. And so if I want to do this in a for loop, what I'll do is I'll do 1 times 2 times 3 times 4 until I get to 5. And then once I'm at 5, that's my factorial. So I will start here. This is for a for loop. Start here, end here for a for loop. Now for recursive, I'm going to flip it. I'll start here, and I will end here. And therefore, since I end here, my base case is 1. And so how do we implement that? Let's do it. So when someone calls factorial function, they will pass the number 5. Let's say. Okay, so first, what is my base case? If n equals 1. Because remember, every time I call, oh shit. What? Every time, really? Why? This is an old solution, guys. Don't look at it until you're ready. Because that one's still recursion, and I'll go over in a bit. Public int factor. Okay, so if n equals 1, return 1. Now, why do we do that? That's our base case. So if we're at 1, don't call the function anymore. Just give me that 1. And so that's my base case. Is I'm telling it I've reached the end. Then here I return factorial. Oh. Okay, and then n minus 1. Why do I do n minus 1? Is because I want to get to that 1. So if I pass 5, is 5 equals to 1? No. So what's the factorial of 4? 4. Is that equal to 1? No. What's the factorial of 3? And this will keep looping until you get to this base case, which will stop calling the function because it returns 1. And so once this returns 1, this will return 1. Then we'll go backwards and we'll return 2 and 3 and 4. But, so here, let me write it out. So what will happen is first I pass in 5, and then 5 will be like, is it equal to 1? No. So it will call the function 4 factorial. But you see, it multiplies. So I got to do that. So I got to do n times, so 5 times whatever this function returns. I don't know what it returns yet. So this will make a new stack call. And I'll be like, okay, so 4, remember, I passed 4 here. So is 4 equals to 1? No. So we'll be like, okay, so 4 times n minus 1, which is 3 factorial. But this will stay in the stack because we just called the function again and we're not done. So we'll have a new function call on the instinct on the stack, which is 3 times 2 factorial, 2 times 1 factorial, and then once it's at 1 is n equals to 1. Yes, this will stop making function calls, and that's what stops the recursion. And so this will return 1, so then 1 becomes here, right? This function now returns 1. 2 times 1 is 3. Oh, sorry, 2 times 1 is 1. This will return it now here. This will become 2. 3 times 2 is 6. This will turn it here. 4 times 6, and so on. What is 4 times 6? 24. And then 5 times 24, which is 48, 116. Wait, no, whoops. That would be 996, right? Oops, oh well. But you get the idea. So that's how it works. Then once this is done, this will return to the original call that called it. And so that's basically how you do it. So you see if I run it. Oh, wow, let's go. Let's see their solutions. How did they implement it? So as you can see, if n equals 1, return 1. And then return n factorial n minus 1. Why did I get the star? I deserve a star for this one. Anyways, so now that you understand, actually let's do a couple more examples, then I'll come back to factorial and teach you guys tail recursion. So bunny ears. How do I do this? We have a number of bunnies, and each bunny has 2 big floppy ears. So if the int of bunnies is 5, it's 5 times 2. Wait, no. It's each bunny times 2. We want to compute the total number of ears across all bunnies recursively without a loop. So I mean, technically, you can, like I said, you can just do return bunnies times 2, but that won't work. So what we'll do is we'll do it recursively, which is first is your base case. What is my base case? Remember, if you were to do this in a for loop, we will take the first bunny, and that will be 2 years, plus the second bunny, 2 years, plus the third bunny, 2 years, plus. So it'll be 2 plus 2 plus 2. Now, flip it. You got to go backwards. So let's say at 5, therefore my base case is when I have only one bunny. And when I have only one bunny, I return 2 years. So if bunnies equals 1, return 2 years. Now, what is my condition here? What am I supposed to return? Well, it's obviously bunny ears because it's recursive. But we want to decrement bunnies because if I don't decrement it, we'll never get to 1. So that's the first thing I do, decrement it. So now what happens is if I pass in 5, this will become 4, and then 4 will run, and this will become 3, then it will become 2, then it will become 1, then 1 will return 2, right? But that doesn't have, like, this will return, so let's say this returns 2, right? But this returns it to the one that was 4, and the 4 returns 2, and they all return 2, and they never add up. And so what I'll do is I'll do 2 plus whatever this returns. Okay, so the way this would work is, let's say I have 4 bunnies. So first I'll call, how many ears is 4 bunnies? Is it 1 bunny? No, it's 4 bunnies. So, well, since we're going to take 1 away, since we're going to call the function, and we're going to take 1 bunny away, right, minus 1. Since we're going to take 1 bunny away, that means we got to add 2. The answer of 3 bunnies, the answer of how many ears 3 bunnies have, the answer of how many ears 4 bunnies have is 2 ears plus how many ears 3 bunnies have. And then that is also how many ears do 3 bunnies have? That's 2 ears plus 2 bunnies. How many ears 2 bunnies have? And then again, 2 plus the 2 ears 1 bunny has. And this will like recursively go. So I hope like that kind of give you guys the idea. And so, oops, forgot semicolon. Stack overflow error. Where am I missing? Oh, it's for when is it 0 bunnies. So when it's 0 bunnies, you could also return 0. That will do the same thing. There you go. I didn't think it'll actually give us 0 bunnies, but they did say they didn't say it's a non-zero number, so you can't assume that. So that is my fault. Let's go next question. Fibonacci. Fibonacci is a little bit of a tricky one because you recurse twice. So how does Fibonacci work? Fibonacci is basically the addition of the last 2 numbers. So 0, 1, and then the addition of these 2 will become the next one. So 0 plus 1 is 1, and then 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, and then so on. All right. So how do we do the Fibonacci sequence? When they give you n, so if you read this question, they're basically telling you, I'll give you n, and give me the Fibonacci number of that nth position. So if I give you, so this is going to be 1, 2, 3, 4, 5, and 6. And so if I give you what's the Fibonacci number at n equals 6, you'll give me 5. And so how do I do the recursive case of 5? Well, if you pass me 5, then what I'll do is 5 equals to the Fibonacci of, if you give me Fibonacci at position 6, not at 5. If you give me Fibonacci, Fib at 6, this equals to, right, Fib, whatever the Fibonacci number at 5 is, plus whatever the Fibonacci number at 4 is, right? Remember, it's the addition of these last 2. And then when I call the functions on these 2 of position 5 and 4, this will make another stack call. This part will make another stack call of what is the Fibonacci, what is the Fibonacci number of 5, which is again, fib at 4 plus fib at 3. And this is going to be, and this will make its own recursion as well. So we'll have two recursions. So you'll see this gets very, very slow. And that's where we'll introduce something called memoization. Not memorization, memoization. And I'll explain more onto that. So now let's implement it. What is my base case? My base case is when, so you see here, these two numbers, if you give me the Fibonacci of 0, that would return 0. But if you give me the Fibonacci of n being 1, that will return 0. And if you give me the Fibonacci of n equals 2, that will give me 1, and so on. So my base case will be when n equals 1, which that returns 0. So if n equals 1, return 0, right? And then we said, how do I get the Fibonacci at some n? 5. It is the Fibonacci at n minus 1, which is the one behind it, plus the second one behind it. I believe that is all it. Whoops. Every time. What am I missing? Stack overflow. It might be because of this. When n equals, I think it's when n equals 0, but that doesn't make sense either. It might be like this. Because the Fibonacci, yeah, something with my base case. Let's see. So if I want the Fibonacci of 5, I want to add 2 and 3. And if I want to add the Fibonacci of 2, I will do 1 and 1. So I'll do Fibonacci of 2 and Fibonacci of the position 3. The Fibonacci of position 3 would be 0 plus 1. And the Fibonacci of position 2 will do minus 0 plus. So we'll have to do when n is less than or equals to 0. Return 0. Huh. Does that not work? So Fibonacci at 2 would equal Fibonacci at 0. But I think it starts, I think that's our base case. We have two base cases in this scenario. So when I do Fibonacci of 2, that is 1. And then when I do Fibonacci of 0, that would give me, and when I do Fibonacci of 1, so when n is 1, that should give me 0. And when n is 2, that would give me 1. I think that's how it's supposed to be. So when n equals 1, then return 0. And if, n equals, forgot the other equal here. And when n equals 2, I'll return 1. I believe that might be, what am I missing here? And if n is at 0, but n will never get at 0 because then I'm returning a number. Unless they're saying, if they pass 0, return 0, yes. Oh, whoops. Just in case they do pass 0. So if it's 1, if n is 0, return 0. If n is 1, unless they're saying, unless they're going by indice, I think that's the mistake. Instead of them passing it like this, they might be going by indice, because if you look at the examples here, 1 gives 1. Yeah, they're going by indice. That's the issue. They're going 0, 1, 2, 3. That's how they're going. So when they pass you 0, you're supposed to pass 0, and when they pass you 1, you're supposed to return 1. Okay, so when they pass, when n equals 0, return 0, and when n equals 1, return 1. There you go. Yeah, so be careful with that. Oh, they do say here, with n equals 0 representing the start of the sequence. Why would you, n usually, like, okay, whatever. N doesn't represent indices, bro. Alright, so now, this is going to be the last one I'll do. And then we will be going into tail recursion. So we have bunnies standing in line, numbered 1, 2, the odd bunnies. So every odd bunny have 2 ears, and every even bunny has 3 ears. Because they each have a raised foot. Huh? Okay, because there's the number of ears in a bunny. Okay, so what is our base case? Well, our base case is when there's no bunnies, right? So when there's only one bunny, we return, remember, if it's odd, we return 2. So that's our base case, and we're working backwards. So if they pass 10, we want to get to 1. So what do we return here? Here is going to be an if statement. So your recursive case is not always return. Like you can actually have for loops within your recursion, and you can have, like we said with Fibonacci, you can have 2 function calls, and you can also have something like this where your function you're calling is within an if statement. So if bunnies module 2 has 0 remainders, that means it's even. And if it's even, we want to return 3 because it's odd plus whatever bunny ears 2, and then we'll have bunnies minus 1. Right, so that's our first case, is when it's odd, we want to add 3. And the second case is basically the same, except, so if it doesn't equal 0, that means it's odd. I mean, we can just do else. Well, actually, I'll do it here just so you guys kind of see it. It's easier to understand. So if it's not 0, that means it's odd, and therefore we add only 2 ears. And that's about it, really. So, oops, what am I saying? Int cannot be converted to Boolean. That might be due to this. Oh, wait, no. This part. Missing return statement, line 14. Huh? Why am I missing a return? Okay. I guess Java is tripping. So if it's even, we'll return this. Else, this is like if else, which is what I was going for. Stack Overflow 7. So do they want it with 0? Return 0. Yeah, they pass you 0. That's, gotta pay attention to these. But that doesn't make a difference. That's just your initial base case you gotta watch out for. But the rest of your code should be right. I mean, even with this, like even with the old implementation, it still worked good. It's just when they passed 2, we weren't covering that scenario. So that's about it. Now let's go to tail recursion. And I'm going to do it with factorial because it's the easiest one to do with and explain to. So remember how earlier we were like, well, we do 5 factorial of 4. And then 4 factorial of 3, 3 factorial, 3, 2 factorial, and then 2, 1 factorial, and then 1. You see, remember how I said this 5, actually I'll also explain it within the code, this will become 5, and it will multiply by the function call, and I'm going to pass it 4, which is 4 factorial. But this first instant of the 5, this 5 instance right here, will never resolve. This will stay in the stack because it's waiting for the factorial of 4. And this will stay in the stack because it's waiting for this. This will stay in the stack because it's waiting for this, and so on. And so once this is complete, then this will get rid of the stack. We'll go back here. This will be removed from the stack and so on. Now this takes memory, and this is linear. And so this is not good. It's inefficient memory-wise, and sometimes it also gets inefficient speed-wise. And so what we'll do is, instead of doing this, why don't we have this function take 2 parameters, the factorial, which is what we want, but also something called an accumulator. Now that also obviously depends on the type of recursion you're making. For our case, we're trying to accumulate them, well, multiply them like the product, but we'll call it like this is the final result. And so by the time, so what we'll do is, okay, so we know 5 times 4 factorial is the same as 3 factorial times 5 times 4, right? And so we can do this and not keep this instance. So we pass this within the next function, and then I'll have, okay, 2 factorial times 5 times 4 times 3. This is going to be like, I'm not going to put it as 5 times 4 times 3. I'm going to actually put in the number of that multiplication. And then I'll have, again, 1 factorial. This will go away. And I'll have, whoops, okay, whatever. 5 times 4 times 3 times 2. Right? And then so on. 5, this will go away. 5 times 4 times 3 times 2 times 1. And you see now, I'm not keeping any of these instances. So the last call, you see here, the last call that's made is the addition of all of them. Well, the product. It's going to be the product of all of them in this case. And that's the last call in the stack, is to accumulate all of them. Here, the last call in the stack was the function itself, which is the tail of the function. That was the last call. And so how do we do this? Now, usually within, actually, this is not too bad. Within your factorial, usually you'll have n, and you have something called an accumulator. But since this is coding bat, you can't change this function because this is how they're calling it. They're not passing an accumulator. So what we're going to do is we're going to remove this. All we know is if n equals 0, return 1. Right, in case they pass 0. Well, they don't pass 0, they pass 1. So we can handle that. But I mean, actually, we don't even need to handle that. We'll handle it within the factorial, just like it worked before. So anyways, back to here. How do we do this? We're going to create a new function. Ooh. Nice. Now we're going to create a new function called public. It's going to return an integer, and this is going to be a helper. This is going to have 2 things. Accumulator. Lol. Listen, I'm not English. So what do we do here? Here you basically do the same thing as you did before with the factorial. So this function, when you call it, is going to return the helper. And I'm going to pass it n. I'm going to pass it 0 as the accumulator to begin with. Now usually, like I said, this you'll, like if you're just coding on your own without coding bat, you'll just put it here. Okay, but in our case, but again, I mean, technically, when you're doing factorial, the person won't know they need something called an accumulator to pass a 0. So you'll even then you'll probably do it like this. Anyways, now into the code. What is my base case with the factorial? If n equals 1, then what do I want to do? Why does my code look like this? That looks so weird. I feel like it changed. Okay, now if n equals 1, what do I want to return? Remember, when I'm here, what I want to return, this is the accumulator. And so I'll return the accumulator. Accumulator. There you go. Else, what am I supposed to do? I want to return, well, I got to call the helper because this is a recursion. What do I got to pass this recursion? I got to pass it n minus 1, right? Which is 4 factorial, whatever it is. And then what I'm going to do is I'm going to take the accumulator and multiply it by n. Remember before, we were doing something like this. Right? This is what we were doing before. But now, remember before, this call will never finish until this returns what it needs. But here, it's not waiting for this multiplication because it's done within the function. And so this will, as soon as this gets called, the instance for this initial run gets off the stack because there's nothing it's waiting for. And so that is basically how you do a tail recursion. Oh, there you go. And so let's see if we are accurate. Whoops. Did we make any mistakes? We made a lot of mistakes. So what do we mess up here? N. Well, because n, the accumulator, we start with 0. It will always be 0, which is a problem. You can see it's always returning 0. There you go. So that was the issue. This is, you see, like simple mistakes like this, that's the problem with the midterm, is that you can't run your code, and nobody, doesn't matter how smart they are, don't make simple mistakes that the compiler will kind of just tell you. Even the prof won't do that. I mean, you've seen the prof teach and he'll do something and you'll get a compilation error. So I don't know why he expects us to just do it as if we have the compiler in our brain, but that's that. Now we are going to go into backtracking. What is backtracking? Backtracking is doing a step, regretting it, going backwards. That's really what it is. And if you go to recursion, these are all backtracking problems. So let's start here. What does it say? Given an array of integers, is it possible to choose a group of sum of the n's? So we want some combination of integers such that the group sum to the given integer. So we're going to do some backtracking. And how do we do it? Assume, so first let me start typing, I guess. For a recursion, for backtracking, it is a recursive case. So you'll do the same thing. You'll need a base case. What is your base case? So we want something to add up to this target. So how about this? We'll take the target, we'll minus something from it. Because remember I said in a for loop, you'll add things until you get to the target. And then in a recursive, you would switch it. So we will minus things from the target. So we know we reach the target if after we minus variables from the target will equal 0. So if the target was 10, oh, actually it's right here. So if the target is 10, what if I do 8 minus 2? So 10 minus 8 minus 2. That will give me the target being 0, which means that's the combination. Therefore, when I reach this, I'll return true. It means, well, this returns a boolean, remember? So that means we have reached such combination that adds up to 10. Okay, so now how do you backtrack? We need 3 cases for backtracking. Okay, one case, so it's actually 4 cases in total. One case will returns true, which is this one. The second case will, so this is the base case. The second case will call this function, but we'll go into, so actually I should probably write this, so kind of, you guys can see it. So assuming I have an array of 2, 5, and 8. And I want the target of 10, and I want to start at 0, index 0 as in. So my start and my target. Okay, so first what I want to do is go at the start, which is 2, right? Which is 2. And then what I want to do is minus it from 10. Then check, is the target 0? No. Okay, so, but now my new target is 8. Okay, so let me go to the next one. 10 minus 5. Is that 0? No. Then I am going to go to the 8. But now I have 3 left, right? So 10 minus 2 minus 5 is 3. Now 8 minus 3, well, that's lower than 0. So what I'm going to do is, well, I've reached the end. How do I know I reached the end? So that is my base case. Is that when I reach the end, is that either the target is 0, which I'll return true, and if the target is not 0, that means this path I chosen is false. So this has to return false. Me trying this has to return false to this call. And then this call will also return false, which will go back to this call. Then this call, since it's false, I'll need another case that will tell me to skip the one after it. Alright? So I feel like maybe if you guys are comfortable with code, hopefully when I code it, it kind of explains itself. Because some people don't really understand English like myself. They understand more code-wise. So you see, this case won't really work because our actual success is once we reach the end of the combo and the target is 0. And we also need, when we reach the end, what if the target is not 0? We gotta return false. So what we'll say is, okay, so once the start is more than nums dot length. I can even do more than or equals to, it doesn't really matter. Then what I'm going to return is target equals 0. So once I get to the end of the combo, is the target equals 0? This will return true or false. Okay, so what calls this function? When someone first calls, I'm going to replace these. So when someone calls 10, and they give me 2, 4, and 8, and here they tell me start at 0. Alright, so I'm going to draw these in instances so you guys kind of understand what really is going on. So the first run is start more than the length. Well, no. So what I'll do is, okay, what do I want to check? I want to check if me minusing the start one from the 10 will result in this returning true. So let's see. So I'll do group. So I'm going to call the function again. I'm going to be like, okay, then start, which is going to be, so start minus plus 1. So I'm going to go to the second one, right? I'm moving on because I'm going to remove this from 10. Just have some patience. So that's the first part. I know I put a bracket. Then I'm going to pass nums, which is the array. Then I'm going to do target minus nums at the start. So I'm going to do first 10 minus 2. And then I'm going to pass it the nums. I'm going to pass it the 4 as a start. So this will become 1. So this is the first instance. Here, let me finish it. If this returns true, that means us removing a 2 from the 10 was a good choice, right? Now here, what do we do here? We're going to do group sum. And what is our goal? We're going to obviously go to the next one. We're going to pass nums just like we did. But what we're going to do is we're not going to minus from the target. Because if this returns false, right? If this returns false, then I want to try skipping whatever this is. Because clearly it didn't work out. So now I'm going to skip it. And I'm not going to remove it from the target because I'm skipping it. Now if this returns true, that means whatever path I chose here is the true one. So I'm going to return true because it worked out. If this also returns false, then I'm just going to return false. It means there's no combo for whatever I'm looking for. So now I'm going to put these as instances so you guys kind of see it. I got to remove space so it's easier. Actually, I'm going to copy this and I'm going to put it here. So it's kind of, okay, let's remove all that. There you go. So this is going to be in start. This is going to be my num. Okay. So the first call I make, which is right here, this will become 0. This will become my 2, 5, 8, and this will become 10. That's what I'm looking for. So now what we're going to do is we're going to replace all these. This will be 3. This will be 1. This will just be the same. And the target will become 10. Minus the num at the start, which is 2. And this one will be 10. And we're gonna like really go through each scenario so you guys really get what's going on. Because backtracking is a little bit confusing. This will become 1. Okay, so this is the first instance. First, we have the start, target, and the array. Is the start at the end of the array? No. So this will not run. Then we're going to call the function again, and we're going to pass it these. So now we're going to call the function again, right? And what are we passing? We're passing this as 1, and we're passing this as 8. Since we're at 1 now, we're at this position, we're at the next step. Are we at the end of the array? So this will become 1. Are we at the end? Not yet. Okay, remember this becomes 2, and this becomes 8, and this becomes 5. So this will call this function again. And this function will go again. Whoops. Remember, this is another instance. It's getting called. Here now we're passing 2. Here we're passing 3, because remember, 8 minus 5, right? And this will become 2. This will become 3. And this will become 3. And this will become 8. So now, what are we doing here? We're doing, okay, well, is 2 more than or equal to 3? Yes. All right, call the function again. So we're going to call it one more time. So this will actually give us a error because this is supposed to be just more than, because you don't want it equals to 3. Because if you do the indice at that, if you do the indice at 3, it will not give you 8, it will give you an out of bound. So that's our first mistake. I would definitely suggest you guys take paper and pen with you. I would suggest you do a cheating sheet because you are allowed 1 page. However, use white paper to write notes. Don't rely on the cheat sheet. It's way better to spend time writing things out on a piece of paper than to look through the cheat sheet. Okay? So anyways, so now these are the calls we're making. Is 2 more than 3? So this never happens. It looks like that. Is 2 more than 3? Yes. Is the target equals to 0? No. And so you see now that's problematic. Actually, wait, now I'm thinking to, is 2 more than, oh, I messed that up. Whoops. Did I mess this up? Is 2 more than the length? My brain is glitching right now. Yeah, this would return false. What am I tripping on? This would return false. So this would be 3. Okay, so now we're going to make another call of this. Sorry, it's been a long day. All I've been doing is code. So this will become 3. This will become -5. And this will become 3. Now, it will be like, okay, is 3 more than 3? Well, no, but it's not equals to 3 either. So, does this run? Oh, I guess it is equal. Look, I wasn't tripping. Why did I question myself? Okay, so is this equal or greater than 3? Yes, because we're at the end of the array. We already minus the 8, remember? We minus the 8. This is now -5. And this is out of bounds, so this will never run. That's why you want to have this condition. So now, is the target, which is -5, equals to 0? This will return false. Okay? Since this returned false, what happens is, remember, this is where this call was. So this will return here false. That means this if statement will never run, which means it will skip to this, and it will run this part. So let's do that. So you see now, it will run this part, which is passing it 1. Actually, I haven't been updating this, so this will pass, what do we have? We have here the start +1, the start +2, and the start +3. Okay, so this is how it's gonna look like. This will be 3, and I gotta also update these ones. Sorry guys, I don't want to confuse you, but this will be 10 minus 2, and then here 8, so this will be 8 minus 5, Just gotta make sure I keep track because I wasn't updating the second if statement. And this will be just like this. It will be 3 minus 8. However, we don't minus them here. So, see, in this second if statement, we never really minus them. We just leave them as is. And you'll see why. When this function, when this function now makes a call to this one, which is this 2, so this is 2, and this is 2 plus 1, 3. So now when this makes a call, it goes to here. Is 3 more than 3? Yeah, well, I gotta put the equal, whoops. Is 3 more than or equal to 3? This now will return false. Why? Because the target, now remember, earlier we checked -5 because we minus the 8. We were at this step. Now, since we called this part, we went backwards. It's called, right? This is the backtracking part. We went backwards to the 5, and now we're checking if only minusing the 5 gave us the target. But this will return false. So you see, this will also return false. Therefore, this whole statement, this whole section will return false. So you see now this backtracking part, we know that this doesn't work. What was that function called by? It was called by this section. False, right? So now since this doesn't run anymore, this runs. And let's do this again. I know it's very, I'm trying to take my time because it is a confusing subject, backtracking. So this is what it would look like. Now what's going to happen, this will be 2. Is 2 more than or equals to 3? No, so this will never run. Now it will go to this section. So I gotta get this part back where it's supposed to be. This will be 3. This will be 8 minus 8. Yes, that's how it's supposed to be. So now this will run because remember, 2 is not more than 3. This call is coming from here. Because remember, we backtracked. Now we're at the 2 and we're skipping the 5. Because we knew when we did target -2, target -5, target -8, that didn't give us target. So then we were like, okay, target 2 minus target 5, did that give us target? No. Now we're going to do 2 and -8. See, that's what this does. Remember, see, it just happened right there, 8 minus 8. This will return true because we know this will become 3, and then we're going to check is target equals 0, which will give us yes. This will return true. Since this returns true, that will return it here as true. And since this returned true, this will run, and that will return it. Who called this function? I believe it was this one. This will return true. And so now this will return true to the one that initialized it, which is, well, that was the initial call. All right, so I hope that I tried to go step by step and take my time with it, but let's see if it runs. Oops, what happened? Bracket, it ends, bracket, it ends, bracket ends, and then bracket ends. Oh, I changed these. There you go. And that's how you backtrack. So there is actually, should I do one more? I should do one more. Okay, so given an array, is it possible to choose a group of some integers beginning at the starting index such that the sums to the given target, however, initial, so this one is actually a little bit tricky. This is a very long one, and I believe it's actually not that long, but if you actually want to cover every case, it's very long, and I don't think they saw it through. This one is very complicated, unless you want to half-ass it, but then that's not the solution, so I'm going to skip it. Given an array, is it possible to choose a group of some of the ints such that the group sums to the given target with this initial constraint? So now you have constraints. Remember, the initial constraint, we were here. For this one, we did have a constraint, is that they're supposed to sum to the target. So with backtracking, you always have a constraint, because if you don't have a constraint, then you never need to go backwards. So keep that in mind. So the group sums to the given target. With this additional constraint, if a value in the array is chosen to be in the group, the value immediately following it in the array must not be chosen. So this is a repetitive from the last one. So you'll always start with start is more than or equals to nums dot length. This will usually be the same for all these questions. Remember, because we still want the sum, right? Given an array, is it possible to choose a group of some of the ints such that the group sums? Yeah, so it's the same. And even the later ones is the same, but for this one, you just want to have a condition. And we'll go through it. So again, we'll do start plus 1. We'll pass it nums, and we'll do target minus nums at the start. And this will return true. So far, we're just copying the same thing, and then we'll handle that constraint. So group no is adjacent, and this will be start plus 1 nums. But this one, we just pass the target because we're skipping. Because if this doesn't give us true, that means we should skip that indice. And so return false. Okay. And then here we return false if they're all false. Now, what is the constraint? The constraint is if the value in the array is chosen to be in the group, the value immediately following it in the array must not be chosen. So remember, this one tells you to include the index within the group. This one tells you to skip that index. Remember, that's what we said. We said 1 chooses that indice, 1 skips that indice. So they're saying if you choose that value, which is this part, if you choose that value in the array, then the one after it cannot be chosen. So if, let's say, my array is this one, 2, 5, 10, 4. So if my start plus 1 is at 5, and I'm choosing that, then 10 cannot be chosen. So the next start is not going to be at 5, it's going to be at 4. Sorry, it's not going to be at 10, it's going to be at 4, so I'm going to skip by 2. And I'm missing a semicolon. What am I missing here? 2, 5. So we did get most of it right, at least. 2, 5, 10, plus 2. I think is this giving me an out of bound? It's returning false. So I might be missing something minor. The start, I believe it might be something here. The start is more than. Let's see if that works. Nope. Yeah, this all gives us out of bound. So as you can see, I've been practicing this actually a lot, and I'm still a little bit glitchy with it, I guess. So 2, 5, 10, 4, and 2, we want to add up to 7. So if I do 2 and 5, I cannot choose. So if I choose 2, I cannot choose 5. So this is returning false, and it's supposed to return true because 2 and 5 add up 7, but I cannot choose 5. 10 and 2 don't work. 2 and 4 don't work. 5 and this 2 work. So if I choose 5, I can't choose 10, so therefore I skip to this. And if I choose this, it doesn't work, so it might be something with the target here. If I don't choose it, what am I missing? I'm actually glitching here. You know what? We're gonna chat and see what I'm missing. I don't want to waste your guys' time, so let's see what I'm missing here. There's a small true and false. Oh, even it could potentially still return true. Isn't this the same code I had? I'm pretty sure this is the same code I had. Where did I mess it up? Hello? Huh? That's the same code I had. Okay, so this is the same. I'm actually being trolled. Oh, lol. It's supposed to be true. I don't know why I put false. I was about to say, hey, yo. Anyway, so I guess I'm not glitchy. So that's really how you do it for recursion. You'll have one base case, which tells you you've reached the end of the array. With backtracking, it's mostly arrays. And the second if statement is if you choose that path. And the second if statement is skipping that path. And that's about it, really. So you have 3 conditions. Well, 4 conditions. 1 is when you reach the end goal. 2 is when you choose a path. 3, when you don't choose a path. And 4, when you choose the path and you don't choose the path and you still have no combinations. That's when you return false. Okay? So, I'm curious if I do need this false. I'm pretty sure you do. Because this will never run after you call this and you call this. Yeah, as you can see, it won't work. So even if you return true, that won't work. So you do have to return false. Because first you'll test this. If this doesn't return anything, you'll test this. And if skipping it also doesn't return anything, you should tell it's false. Like, hey, yo, I tried it, didn't work. I skipped it, it didn't work. And so that's about it. For this part, really, you can just do. Can I do this? But I do need the if statement. Okay, that's about it, guys. So that is backtracking recursion and tail recursion. Memoization, I'm not going to really go over memoization too much because it's a very simple concept. So I'm just going to teach you guys the idea behind it. And it's easier to do with Fibonacci. So remember in Fibonacci, we were calling it twice. Now, the problem here is instead of me calling it twice, for example, Fibonacci of 5 is, so fib of 5 equals fib of 4, right? Times Fibonacci of 3. So this, wait, is it? Fibonacci of 4. I think I meant, no, it's 4, whoops. So this would be 5 times 4 factorial, 4 times 3 factorial. So the problem here is that you don't want to have duplicate calculations when it comes to things that are very lengthy. And I believe, oh, this is factorial. What am I tripping? Guys, too much code. Too much code. This is supposed to be plus. I'm actually tripping. There you go. So, okay, now I can tell you what the problem is. I was saying yo, okay. So the problem here is this will make another call of Fibonacci of 4 equals fib of 3 plus fib of 2. Okay? So you can see I'm trying to find Fibonacci of 3 and Fibonacci of 3 again. And so this gets very bad when I do this. Watch this. Fibonacci of 100 equals, right, fib of 99 plus fib of 98. And then if I do, well, it's not going to be 99. Assume this is the positions. N. Assume this is N, not the actual Fibonacci. So then what's going to happen is this is going to have 1, which is fib. And you can already see how bad this will become. This will become of 98 plus f of 97. And this will also have that. But if I'm calculating it here, why am I calculating it again here? And Fibonacci is a very long sequence. And so that's where you use something called memoization, which is basically you'll just create an array. And then what you'll do is whenever you calculate something, you'll put it in the array. And then before you call Fibonacci of 98, like here, what you'll do is you'll check the array. Is Fibonacci of 98 available? If it's available, then you just take it right away instead of calculating it. That's basically memoization. And that's all there is to it. And that's about it. So, long lecture for this one, but because most of the midterm is on it, that's why I really want to take my time with it. So that's about it, guys. I will see you guys in merge, quick, and counting.